Okay, this is going to be a A8 practice test. I'm not saying this is exactly the kind of questions you're going to see on your ASE A8, but we're going to shoot through some of these things and see what we do, if we can think the right way whenever we're looking at these various systems. Some of these are engine related, some are emission related, but we'll jump into this thing and see what you guys think about it. Let me know. Question 1. An engine's been removed from a high mileage rear wheel drive vehicle and totally resealed for several serious oil leaks. A few thousand miles later, the engine returns with leaking valve covers and a seeping engine oil pan gasket. What might cause this? There's your choices. Sealer wasn't used, PCV system issue, wrong engine oil, or cheap gaskets. Question 2. A customer complains that her gas pedal sticks at the top of the travel and pops loose as she continues to apply foot pressure on the pedal. This problem is due to what? Maybe a sticking throttle cable, warped throttle plate, dirty throttle body, damaged TP sensor. Question 3. A P0401 code will probably be due to which of these? Stuck open IEC, canister purge, small evaporative leak, or clogged EGR passage. Question 4. A suddenly misfiring spark plug will cause the O2 to indicate what kind of exhaust? Rich, lean, hot, or cool? Question 5. An air leak between the mass airflow sensor and the throttle body will cause which of these? Positive short fuel trim correction, negative long fuel trim correction, oxygen sensor failure, or canister purge failure? Question 6. After work done in a body shop, a no start condition is being investigated. There's no communication with the scan tool and no reference voltage is present at any sensor. Is this a coincidental failure, faulty PCM ground, ants in the PCM relay, or a smoked module, which is the most likely cause? Question 7. An engine with an overheating issue started after a 6-hour cold soak and allowed to run for 60 seconds. The radiator cap is removed and a hissing sound is heard. This means A, the cap bypass valve is stuck. B, the heater core is rust plugged. C, you have a head gasket fire ring breach. Or D, the cooling system is straight water. Question 8. A loose fuel filler cap will set which one of these codes? 455, 401, 340, or 711? Question 9. Variable cam timing in 1995 was originally used only for A, NOx emissions, B, enhanced EGR, C, cruise control, or D, cat monitoring? Question 10. Retarded cam timing or retarded ignition timing on a speed density map fuel system can cause A, low engine vacuum, B, rich air fuel mixture, C, late transmission shifts, D, any or all of the above. Question 11. An early 70s Chevy pickup has been upgraded with a fuel-injected speed-density map system engine that has been built with an aggressive cam. The engine runs very rich at idle, but not at road speed. Is that low intake vacuum when at idle, low octane gas being used, the EGR valve should be deleted, or the TP sensor is scratchy at idle? Question 12. An engine is being checked for rough idle. The intake vacuum is 14 inches idling. The cam timing and ignition timing have been verified as correct. What might be the cause? PCV sludge buildup, low fuel pressure, EGR stuck open, or clogged air filter? Question 13. Since diesel engines regulate power and speed with fuel delivery, why does this 6-liter Power Stroke need a throttle plate? Is it to prevent over revving, to facilitate EGR flow, to regulate road speed, or to enrich fuel mixture? Now here's the answers and the explanations. This is going by pretty quick, so let's talk a little bit. An engine's been removed. This is the one, whenever the thing comes back for oil leaks after it's just been resealed, and I've run into a similar situation to this with a clogged PCV system on both sides, can pressurize the crankcase and cause oil leaks due to blown gaskets and seals. That sounds preposterous, but when I was at the dealership, there was a guy, one of the line mechanics over there, who replaced resealed the entire engine. It was a 4.3 liter in a van, in a Chevy Astro van, and it seemed like it belonged to a vendor that we, somebody that we had a contract for, whatever, Coca-Cola or somebody. Anyway, they gave it to me to check out the emission system, and I got to checking everything out because it was supposed to get a full checkout and all that. PCV system was totally clogged on both sides. That's why every gasket and every seal on that engine was leaking, and the guy that fixed it didn't even consider why all the stuff was leaking. He just fixed the leaks. If you just fix the leaks without finding out what caused them in a situation where everything's leaking, then crankcase pressure, you know. So of course you can have one that all the gaskets are leaking on that doesn't have a crankcase pressure issue, but it's doggone sure something you need to check. And I found that. Of course it didn't go and leave and come back, but it would have if I hadn't done that. This one here was very common on older throttle cable equipped engines. Dirty throttle body would cause that throttle plate to stick. It'd feel like you're standing on a brick, and then all of a sudden it'd pop loose. Now the reason that's dangerous is because you can, let's say that, and I feel like this is probably what happened to this one lady. Was she lived across the road from a pond. She had a vehicle that had a throttle cable. I mean, I knew from the year, model, and which vehicle it was. It was one of those that was susceptible to having this problem. And for some reason that nobody ever figured out, she backed right across the road into the pond, and the vehicle sank and she drowned. And she'd been backing out there every morning for long years, and that one morning this happened. And they didn't ever come to this conclusion, but I expect she probably tried to back up, and this was like 40 years ago. She probably tried to back up with it in reverse. She already had her foot off the brake, and when that thing popped loose, it was a little bit downhill anyway, and it took off in reverse, and the faster it goes in reverse, the more it throws you against the gas pedal, and she couldn't stop that thing, and it went straight across the road into the pond. And I'm just assuming that's probably what it was. Nobody ever asked me, but when I read about that, and they were talking about what a mystery it was that she did that, you know, that's most likely what the cause of it was, because that particular vehicle she was driving, I knew those were susceptible to have that, and it was a Ford. P0401 code probably be due to clogged EGR passages that will restrict EGR flow and cause this sludge. This sludge right here is doggone incredible how it builds up and comes out here. The EGR valve goes over here, EGR goes through here, and it goes into the throttle body, so every cylinder will get the same amount of EGR. Well, in this case, no cylinder was getting any EGR because both of these had piled up this sludge that clogged that thing up. That's a fairly common situation there on just about any make of car. Suddenly misfiring spark plug will cause the O2 to read a lean exhaust because there will be unburned fuel in the exhaust, but the O2 sensor only sees air. That'll trip people up because they're thinking fuel, they think rich, but the oxygen sensor couldn't care less about fuel. Air leak between the mass airflow sensor and the throttle body will cause a positive short fuel trim correction because the O2 sensor will report a lean condition and the PCM will add fuel to compensate for it. Something else that can happen because of this situation here is if that engine torques so that it opens up that crack when it's torquing, it will cause it to, you know, lunge. It'll go, as soon as it opens up a crack, it loses power, and then the engine detorques, and then it closes the crack. It goes back and forth, boom, boom, boom. I've seen that before too. This right here was one. I've seen this before. The guy had the body shop. He said we did a bunch of work on it. We did some welding on it, but now it won't start. But we had disconnected the battery. I don't know why this happened. Well, if you ground the clamp to the frame and you weld on the body, then that voltage is subject to run through the, you know, the secondary, you know, the grounds to the between the body and the frame, and find a module. And you got, you know, 240 volts going through there. It's bad, and we had to put an engine controller on that one, but it was a smoked module. I happened to have an engine controller that would plug into that thing. Wasn't the right one, but it would plug into it. It was a Dodge truck, and I just happened to have one in my junk. And I plugged that thing in, and I was able to get communication. But when I plugged in the original one, I wasn't. The only way to prevent this is to ground the clamp right close to where you're welding instead of grounding it at the back of the vehicle and welding in the front or something like that. Or if you disconnect the modules that you want to protect. Of course, nowadays you got 30, 40, 50 modules. And so I would definitely make sure that at the very least I unplugged the PCM, but it's best, you know, and disconnected the battery too. Disconnecting the battery by itself is not going to protect that PCM from being messed up by welding. Engine with an overheating issue. Watch this.
That is what a blown head gasket acts like. It's pushing, keep doing it again. Pushing that smoke out there. And we also got a little bit of, do that again. Whenever you put the cap on, it pushes water out past that radiator hose, but it's definitely getting pressure in the cooling system. Head gasket time.
Now, granted, that's a lot worse than just a little bit of pressure buildup in the cooling system. It's an extreme example of it. But if you got one that's got an overheating problem, and you're trying to determine if it's got a blown head gasket, you hear that hiss when you take the radiator cap off. You can also use you know, rubber band or tie wrap a natural glove over the radiator fill neck, and if it begins to inflate that glove as soon as you start the engine, then you know there's some pressure getting in there from the head gasket. This will typically be a PO 455. I think I told you about one time the service manager knew it was 5 till 12. And he knew I was getting ready to go to lunch, and he came and found me, and he says, if you'll go out here and look at this Lincoln and find out why the check engine light's on before you go to lunch, I'll buy your lunch. I said, okay. So I went out there and plugged in the scan tool and pulled up a 455 code, and I went back there, and the gas cap was swinging around, dancing around loose. You know, it wasn't swinging by its tether, but I tightened it up, click, 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 cleared the code, and I said, all right, I took care of it. Now, he didn't buy my lunch because I was through right about 12 o'clock, and so he thought it was going to be a long, drawn-out process and everything, but he didn't make good on his promise. Whatever, you know, I had the money to buy lunch anyway. Variable cam timing was originally used on the 1995 Contour. It would close the exhaust valve early to trap some of the exhaust gas in there so it wouldn't have to have EGR. And of course there were some vehicles that managed to pass emissions muster without EGR anyway. Some of your little 2.9s had a plug over where the EGR went from the factory and all that because they could do that. Jeep Cherokees didn't have an EGR valve, and they didn't have variable cam timing either. And on the 95 Contour, the only reason that variable valve timing was there was to close the exhaust valve early when you're cruising down the road, and it would keep you from having it, let them meet NOx requirements. What it basically amounts to. Retarded cam timing or retarded ignition camming on a speed density map system can cause low engine vacuum, rich air fuel mixture because of the map is reading that and thinking it's load, or late transmission shifts. You see, so if you're having to go deeper into the throttle because you don't have enough power because you got retarded cam or ignition timing, then it's going to cause the transmission to shift harder on those that have a throttle cable or even a modulator valve. Early 70s Chevy pickup, okay. I ran into this on a 73 Bronco. Low intake vacuum. If you measure the engine intake vacuum on an engine with an aggressively ground camshaft, it's going to be lower than on an engine with a, you know, with a smooth camshaft. The camshaft designed to make the engine idle smooth is going to have better vacuum, or, you know, good strong 18 to 22 inch vacuum whenever it's idling. If it's got a cam in it, it ain't going to be like that. You know how they run so rough when you put a cam in them. The more aggressive the camshaft, the rougher they run. Well, a 73 Bronco had been upgraded to a fuel-injected 5-liter Mustang, and that guy was grumbling because it was idle really rich, but it ran normal going down the road. And so I went up and had to put a mass airflow kit on it. That probably costs more than that now, but this was a long, long time ago. It came with a PCM, some harness wiring where you had to go into particular pins in the engine controller harness, and it had a little adjustment block where you could adjust with a, you know, and it had a little liquid crystal readout there where you could adjust the mass airflow, kind of like adjusting a carburetor. I thought that was really cool. That took care of his problem though, because he didn't need the map sensor reading vacuum to determine engine load. Low vacuum at idle, or if you disconnect that, you know, it's going to make black smoke. So engine being checked for a rough idle, vacuum 14 inches idling. Cam timing and ignition timing have been verified. EGR stuck open. I said this on a previous slide. When the EGR is flowing at idle on a gas burner, it'll have low intake vacuum, And the manifold will get hot within about a minute after the engine is started. So that's the answer to that one. Alright, this is cool. It says diesel engines regulate power and speed. Alright, I did not gray out the wrong answer. This basically is to facilitate EGR flow. Sorry about that, I messed up on that slide. But when the engine's running, intake air is above zero, the PCM may partially close the throttle plate to create low pressure so EGR will flow. Now that's a picture that I took at the engine plant when I went up there in 2003 to the Power Stroke engine plant in Indianapolis. That's a cutaway of the 6-liter. Now they basically came up with a different way to do that without a throttle plate. Some of your Duramaxes have throttle plates too. So this is not just a 6-liter thing. If you see a throttle plate on a diesel, that's usually what it's for, is to facilitate EGR flow. But on the later on, a couple of years later, when they got into the to the bigger Power Stroke engines, they would actually put a scoop in there so that when the EGR started trying to flow, it would the air flowing through the exhaust had a scoop that would capture that, and they didn't need the throttle plate. So there's different ways of handling this. Well, that's all of it. I hope you guys did well. I hope you enjoyed running through this test. We've only been here for about 16 minutes, so maybe you made it to the end. Let me know what you thought about this, and I'll see you next time.